Factories have always been places of incredible innovation. From the first conveyor belts to the massive robotic arms we see today, the goal has always been to build things better, faster, and safer. Now we are standing on the edge of the next great leap forward. Imagine walking onto a factory floor and seeing workers that look and move just like us. These aren't science fiction movie props. They are humanoid robots, and they are starting to join the workforce. These machines are designed to operate in spaces built for people, using the same tools and navigating the same pathways. They represent a fundamental shift in how we think about automation, bringing a new level of flexibility to manufacturing lines. The idea is simple but revolutionary. For decades, industrial automation has meant huge, stationary robots bolted to the floor. These machines are incredibly good at doing one specific task over and over, like welding a car door or lifting a heavy engine block. However, they are not adaptable. If you want to change the production line, you have to reprogram or even replace these massive installations. Humanoid robots, on the other hand, are designed to be general-purpose workers. They can be taught to do one job today and a completely different one tomorrow, just by updating their software. This adaptability is what makes them so exciting for modern manufacturing. So why now? What has changed to make these walking, working robots a reality? It's a perfect storm of technological advancement. The processors that act as their brains are more powerful than ever, allowing them to learn and make decisions in real time. The batteries that power them are lighter and last longer, letting them work a full shift. Most importantly, the artificial intelligence, or AI, that guides their movements and actions has become incredibly sophisticated. These robots are no longer just following a pre-programmed path. They are observing, learning, and interacting with their environment in a way that was unimaginable just a few years ago. This new wave of automation is not just about replacing old machines, it's about fundamentally rethinking the factory itself. Businesses are looking at humanoid robots to solve some of their biggest challenges, like persistent labor shortages and the need to keep production running around the clock. A robot doesn't get tired, it doesn't need breaks, and it can perform repetitive tasks with perfect consistency. Companies and industries from automotive manufacturing to warehouse logistics see these robots as the key to staying competitive. They are investing billions of dollars to bring this vision of a collaborative human-robot workforce to life, and it's happening faster than you might think. Creating a robot that can walk, grab, and work like a person is an incredible engineering challenge. It all starts with the skeleton. These robots are built using lightweight yet strong materials like aluminum alloys and carbon fiber, much like a high-performance race car or aircraft. Inside this frame, engineers place a complex network of motors and actuators. These are the robot's muscles. Instead of large, bulky motors, many modern humanoids use advanced electric actuators that are small, powerful, and precise. This allows them to replicate the fluid, dynamic movements of a human body, from the gentle grip of a hand to the steady balance required for walking. The real magic, however, is in the robot's nervous system. This is a web of sensors that feed information to its central computer or brain. High-resolution cameras in the head act as its eyes, allowing it to see the world in 3 dimensions and identify objects. Force sensors in its hands and feet let it feel how hard it's gripping something, or how firmly it's standing on the ground. Other sensors, called inertial measurement units, help it maintain balance, just like the inner ear in a human. All of this data is processed thousands of times per second, giving the robot a constant awareness of its body and its surroundings. Making these robots move naturally is one of the biggest hurdles. Early robots had clunky, pre-programmed gaits, but today, companies are using a technique called reinforcement learning. They create a highly detailed digital copy of the robot in a computer simulation, a digital twin. In this virtual world, the AI can practice walking, falling, and getting back up millions of times in just a few hours. It learns through trial and error what works best, developing a natural, stable way of walking. When this learned behavior is loaded into the physical robot, it can walk with a smoothness that is astonishingly human-like, as seen with Figure AI's Figure 02 robot. But walking is only half the battle. To be useful, these robots need to interact with the world. This is where artificial intelligence and large language models, or LLMs, come in. Think of LLMs as the part of the brain that understands language. You can simply tell the robot, "Please pick up that box and put it on the conveyor belt." The AI translates that command into a series of actions. It uses its vision to find the box, calculates the best way to grab it, and executes the task. This ability to understand natural human language makes training these robots incredibly intuitive, bridging the gap between human supervisors and their new robotic coworkers. The quest to build the world's best humanoid robot has become a full-blown international competition, primarily between the United States and China. These two countries are pouring immense resources into research and development, viewing leadership in this field as critical for future economic and strategic power. In the United States, a cluster of innovative companies is leading the charge. You have Tesla with its Optimus robot, which aims to leverage the company's AI expertise from its self-driving cars. Then there's Boston Dynamics, famous for its incredibly agile Atlas robot, which was recently acquired by Hyundai to be integrated into its own advanced manufacturing facilities. Other major American players are making huge waves as well. Figure AI has already started deploying its Figure 02 robot for commercial tasks, showing that these machines are ready to leave the lab. Agility Robotics Digit is another pioneer, with its unique design optimized for logistics and package handling in warehouses. These companies, along with others like Aptronic and 1X Technologies, are part of a vibrant ecosystem that is pushing the boundaries of what's possible. This American effort is backed by massive private investment and a clear goal to build a domestic robotics industry that can power the next generation of manufacturing. Meanwhile, China is not just participating in this race, it is determined to win it. The Chinese government has made humanoid robotics a national priority. In 2024, the Ministry of Industry and Information Technology, or MIIT, laid out an ambitious plan to achieve mass production of humanoid robots by 2025 and to establish globally competitive Chinese brands by 2027. This government-led strategy is designed to address the country's rising labor costs and aging population by creating a tireless, efficient robotic workforce. It's a top-down approach that aims to rapidly scale up production and deployment across the nation's vast industrial sector. The list of Chinese companies in this space is growing rapidly. Firms like Unitree Robotics, with its H1 and G1 models, and Fourier Intelligence, whose GR1 robot can carry a 50-kilogram payload, are demonstrating impressive capabilities. They are joined by a host of other ambitious startups like Robot Era and Xpeng's robotics division. While the US may currently lead in cutting-edge AI software, China's manufacturing prowess gives it a powerful advantage in building the hardware at scale. This intense competition is accelerating innovation at an incredible pace, bringing the future of robotic labor closer every day. The most immediate impact of humanoid robots will be felt on the factory floor, but their potential extends far beyond manufacturing. The core benefit for any business is simple: economics. The industry is aiming to reduce the cost of a humanoid robot to around $30,000 within the next decade. When you consider leasing options, the operating cost could drop to as little as 40 cents per hour, compared to human labor, which can cost $20 per hour or more in some places. The financial incentive is undeniable. These robots can work 24/7 without sick days or vacations, dramatically boosting productivity and efficiency for businesses that adopt them. We are already seeing the first wave of these robots being put to work. As of 2025, companies like Agility Robotics and Figure AI have begun commercial deployments in real-world settings like warehouses and automotive plants. In these environments, robots are tasked with dull, dirty, and dangerous jobs. This includes moving boxes, loading and unloading parts from assembly lines, and performing highly repetitive quality inspections. By taking over these physically demanding or monotonous tasks, the robots free up human workers to focus on more complex problem-solving, system oversight, and creative work that machines can't yet handle. Looking ahead, the applications for these robots are virtually limitless. After proving their value in factories and warehouses, the next frontier will be healthcare, especially in elder care, where they can assist with daily tasks and provide companionship. We will likely see them in the service industry, stocking shelves in retail stores or assisting in hotels. Beta testing for use in private homes, helping with chores like laundry and cleaning, is expected to begin as early as 2026. The same technology that allows a robot to navigate a factory floor can also help it navigate a hospital corridor or a living room. This transition will undoubtedly reshape our world. For companies, It presents a massive opportunity to overcome labor shortages and increase output. For workers, it signals a shift in the nature of work itself. While some jobs may be automated, new roles will be created in robot maintenance, programming, and management. The rise of the humanoid robot is not just a story about new machines, it's a story about the future of labor, productivity, and human ingenuity. We are building a future where humans and robots work side by side, collaborating to achieve more than we ever could alone. It's going to be an exciting ride.